But if y'all look at the data, right, we actually find something out, right? We see a trend. Okay, we can see a trend when you plot these data points. Okay, and we can basically figure out a math relationship between the two. Okay, so for instance, let's say I got some data here. Let's say that I got my A, in this case my concentration, then I got my rates over here. Once again, concentration is in molarity. My rate, we know, is molarity over time. In this case, for seconds, is on the bottom here, right? So seconds minus 1 just means that it's molarity over seconds, right? Now, I have my concentration with my rate, concentration with my rate, concentration with my rate, concentration with my rate. So what we find out, right, is that we find that as concentration of A doubles, so if your concentration doubles, the rate of the reaction will double. Okay, and this is the case for basically all of our anything dealing with kinetics. If you double the concentration, your rate will double. Right. So if we look here, right, 8 right here, I'm at 0.5. And then notice my rate is 7 times 10 to the negative 3. If I double my concentration to 1 molar here, what happens to my rate? It's doubled from 7 times 10 to the negative 3 to 14 times 10 to the negative 3. It's doubled. All right, because we're adding, right, more of A, okay, which we're going to get to that in a bit here. Or, for instance, notice, right, this math relationship goes both ways, right? So, for instance, if I doubled going this way, my rate doubled. But what if I cut that in half, right? What if I go from 0.5 concentration to 0.25 concentration? What's going to happen to my rate? Well, my rate is going to be cut in half as well, from 7 times 10 to the negative 3 to 3.5 times 10 to the negative 3 here. Okay, so it's a two-way street here, right? You double it, your concentration, your rate will double. If you cut your concentration in half, your rate will be cut in half. All right. So this led us to this math relationship here. Rate of reaction equals K times your concentration of your reactant. So basically, we call this math relationship the kinetic rate of expression. Okay. So basically, our rate of reaction equals K times our concentration of our reactant. All right.